Alright, so yesterday we looked at sequences. Now today we're going to look at something called a series. And what a series is, it is what you get when you add all the terms of a sequence. This result is called a sum. And there's a special notation for this called summation notation, or also known as sigma notation. And it looks like a weird big looking E. This is the Greek letter sigma. And we have a couple things going on here. At the bottom, we have n equals 1. This is your starting point. So the first value you would plug in. You will have a number up here. This is your ending point. And then you'd have your function. So what this means is that I'm going to plug in 1 into this function, get a number, plug in 2, get another number, 3, 4, 5, 6, 7, and I'm going to stop because 7 is my ending point. I would get those answers, and then I would add those all up. And that's what the sum would be. Alright, so let's look at some examples. So in this, we have our function 2n, or 2 minus 3k. We're going to start by plugging in 3 for k, and then we're going to keep going up by 1 until we plug in 5. So we're going to do 2 minus 3 times 3, which equals negative 7. 2 minus 3 times 4, which equals negative 10. And 2 minus 3 times 5, which equals negative 13. So now I'm going to add these three things up. So negative 7 plus negative 10 plus negative 13, and that equals negative 30. So our sum is negative 30. Now because we're just subtracting 3 each time, this is a arithmetic sequence. We're adding negative 3 each time. Alright, so let's look at letter B. Letter B, I'm going to start by plugging in 1 for I, and then keep plugging in larger numbers until I get to 5. So negative 2 to the first power is negative 2. Whoops. Let's zoom back out a bit. Negative 2 to the second power is positive 4. Negative 2 to the third power is negative 8. And I'm just getting these from typing them into the calculator. Negative 2 to the fourth power, that is positive 16. And negative 2 to the fifth power is negative 32. So then we need to add these up. Negative 2 plus 4 plus negative 8 plus 16 plus negative 32. So we type that all into the calculator, and we get negative 22 is our answer. Right, now we got to determine, is it arithmetic, geometric, or neither. We're multiplying the previous answer by negative 2, so since we're multiplying by the same amount, this is going to be geometric. Alright, let's look at example C and D. Alright, so this one, our function is k squared minus 2. We're going to start plugging in 3 for k and go up to 7. So we have 3 squared minus 1, which is equal to 8. We then have 4 squared minus 1, which is 15. We have 5 squared minus 1, which is 24. We have 6 squared minus 1, which is 35. And then we have 7 squared minus 1, which is 48. So then we're going to add these up. You add 8, 15, 24, 35, and 48. And when you add all of those up, you should get 130. And we are not adding or subtracting the same value each time. You know, from 8 to 15, we're adding 7, then we're adding 9, then we're adding 11, and then we're adding 13. So we're not adding the same value, and we're not multiplying by the same value each time, so this is neither. Alright, letter D. This one is just negative k. And we're going to start by plugging in 1 and going up to 6. So negative 1, well, that just equals negative 1. Negative 2 equals negative 2. So you can see that this is just going to be the same value. So for the sake of time, I'm just going to add negative 1 plus negative 2 plus negative 3 plus negative 4 plus negative 5 plus negative 6. And that gives us negative 21. So the numbers are going up, or sorry, the numbers are going down by 1, or adding negative 1. Since we're adding the same amount each time, this is arithmetic. And it is arithmetic. So one of the things you could think about is if this function is linear, then you know it's going to be arithmetic. You know, let's look at our other arithmetic one. Here, 2 minus 3k. That's a linear function. Think of it as 2 minus 3x. You guys know that this is a line, so it's going to be an arithmetic function. And that might make things a little bit easier for you. Alright, let's look at the next page, please. On this page, we're going backwards a bit. We have the summation right here, or the numbers that we'll be adding up. Now what we need to do is give the sigma notation for it. So we can see that we are adding 5 each time. Okay, so we're adding 5 each time. And our function's 5n. And we start at 1 and go to 1, 2, we have 1, 2, 3, 4, 5, 6 terms. So you can kind of check yourself and see if you're right. If you plug in 1 here, right? You plug in 1, you get 5. You plug in 2 for this, you get 10. You plug in 3 for this, you get 15. So you can do this to double check to see that you have this part correct. You can just kind of plug in your values and see if you get the correct term up here. If I plug in 5 for n, 5 times 5 is 25. Is the 5th term up here 25? Well, we have 1, 2, 3, 4. Yep, the 5th one's 25. So we know we're in good shape. Letter B. we have 1, 1 over 8, 1 over 27, and 1 over 64. So we've seen this before where 2 to the third power is 8, 3 to the third power is 27, 4 to the third power is 64. So our function here is going to be 1 over n to the third power, and we're starting at 1, so n equals 1, and we stop at the fourth one. So again, think about it. If I plug in 1 for n right here, I get 1. If I plug in 3, I should get 1 over 27, which is the third term. So we have the first, second, third term. So again, it's easy just to double check yourself to make sure you've gotten the correct answer right here. All right, let's go look at letters C and D. So C and D has these 3 little dots. What that means is that the pattern is going to continue up until 77. So we have 7 plus 14 plus 21 plus, well, keep adding 7, 28 plus 35 plus 42 plus 49 plus 56 plus 63 plus 70 plus 77, and that is where we will stop because of this 77 right here. So this is my sequence all written out, or my series all written out. So we have our summation notation. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n equals 1 up to 11. And we're just adding 7 each time. So 7n. And that becomes our answer. Now, you may be sitting there and thinking, well, why don't we go backwards 1? Well, look, if we went backwards 1 and said, okay, what would go back here? In this example, it'd be 0. We don't need to add that plus 0 at the end. So it's just 7n. All right, now for letter D, we see these 3 dots again, but nothing after it. What that means is that the top part of our sigma notation will be infinity, because it's going to go on forever. So we could not actually calculate this because the numbers will keep getting larger and larger forever. So we see what's going on here is that we have -4, then we go down to -8, then we go down to -12. So we're subtracting 4 each time. We're subtracting 4 each time. And look, if we were to go 1 backwards, like I said before, 0. We would have 0. So 0 minus 4 gives us -4. So we have -4n. Again, we don't need to write that plus 0. It doesn't make sense. So that is our summation notation. Okay, when we look at example 3, though, we're going to see that going backwards in that one will not give us a 0 as our starting point. So let's go down and look at that. So an employee at a construction company earns $33,000 for their first year of employment. Employees at the company receive raises of $2,400 each year. What will the employee's salary be for the first 5 years? Okay, so year 1, we were told is $33,000. Year 2, well, we're going to add $2,400 to this, and that will give us $35,400. Year 3, we're going to add another $2,400, and that's going to give us $37,800. Year 4, Year 4 equals $40,200. And then finally, year 5 is $42,600. So I just added $2,400 to each of the previous years. And we only went to 5 because it said 5 years. Now, write a rule to determine the employee's salary for the nth year. So we want to write AN equals something. Well, we know that we get paid $2,400 every year. So it'll be 2,400 N. Now we have to figure out what our y-intercept or our starting value is. Well, in year 1 we got $33,000. That's not our y-intercept, because if we plugged in 1 for N, we would not get $33,000, which is what we want to get because that's what the problem says up here. So we want a y-intercept that when I plug in 1 for this function, that we get $33,000. So what we'll need to do is go backwards 1. So $33,000 minus 2,400, and that gives us 30,600. So that is our y-intercept. So now we could plug in any value of n to this function or this rule, and it will tell us how much the guy made that year, or that employee made. If you plug in 5 for that function, we should get 42,600. Oops. If we plug in 4, we should get 40,200. Right. So again, double check. Right. Last but not least, part C. Find the total amount of money the employee will earn working for the company for 6 years. Well, we got, oops. We got all this information in part A. Well, we can find out year 6 by adding another $2,400, and we will get 45,000. So we'll just add up all 6 years in part A. So go out and get your calculator, add all of those up, and you should get $234,000. So this lesson we're just adding or subtracting some things to get our rule or to find our sum. So I hope that you guys are doing okay with this. Go ahead and try the homework, and good luck.